Welcome to the Agile Software Engineering Deep Dive, the podcast where we unpack the ideas shaping modern software engineering. My name is Alessandro Guida. I've spent most of my career building and leading software engineering teams across several industries. And today I want to talk about something that seems to be everywhere right now. Agentic AI. It feels like suddenly everyone is building AI agents. Agents that plan, agents that reason, agents that automate entire workflows, sometimes even agents that promise to replace entire teams. Listening to all this, I started feeling slightly confused, not because the technology itself is mysterious, but because the explanations often are. So I did what engineers usually do when confronted with hype. I tried to strip the idea down to its fundamentals. What exactly is an AI agent? What is actually happening under the hood? And how much of the current excitement comes from engineering reality versus marketing language? Because when you look closely, many so-called agents are simply language models connected to tools through APIs, executing actions across systems. Powerful? Yes. Magical? Not really. And once you connect AI systems to real infrastructure, calendars, emails, ticket systems, databases, the interesting engineering questions begin. Questions about reliability, about control, about observability, and about whether we are adopting these systems at the speed of engineering maturity, or simply at the speed of hype. In this episode, I try to demystify agentic AI, walk through a simple example of how agents actually work, and reflect a little on why the conversation around them sometimes feels strangely familiar. So let's take a calm engineering look at what's really behind the idea of agentic AI. Let's dive in.
Welcome to the deep dive. If you're joining us today, you are probably here because you want to cut through the massive, overwhelming information overload surrounding the absolute biggest buzzword in tech right now.
Oh, it is everywhere.
Right. You've seen it on your feeds. You've heard it in endless strategy meetings. And quite frankly, you might be experiencing a little bit of FOMO.
The fear of missing out.
Exactly. So the topic today is agentic AI. And we are pulling from a highly candid, just wonderfully no-nonsense source article titled Agentic AI, the world's most expensive if this then that. Our mission today is to figure out what is real, what is pure marketing glitter, and what you actually need to know to navigate this space.
It really is the perfect time for this specific deep dive because the hype cycle is currently at a fever pitch. You really can't escape it anywhere in the business world.
No, you can't. I mean, it feels like every business show or tech blog out there features some CEO confidently claiming that agentic AI is going to, totally redefine productivity or reshape the workforce.
Oh yeah, they make it sound like if you aren't deploying a massive fleet of autonomous AI agents right this second, your business is basically a dinosaur just waiting for the meteor.
Waiting for the impact.
Right. What's fascinating here is the stark contrast between that breathless CEO hype and the reality on the ground with the actual engineers. In the source material, the author points out a highly revealing scenario.
Yeah, the chief AI engineer story.
Exactly. You have a chief AI engineer leaving a company to jump on the agentic AI bandwagon, but under even mild pressure, they'll admit that the code powering these revolutionary agents is, it's not that great.
It's brittle.
Very brittle. The underlying tech is brittle, and you still have to constantly watch out for hallucinations. The marketing is basically running a marathon while the actual engineering is still tying its shoes.
That gives us a serious case of deja vu, doesn't it?
Mm-hmm.
I mean, the source lists out some of the greatest hits of tech hype cycles past. If you've been around the block, you remember these clearly.
Oh, definitely.
In the 90s, everyone promised the paperless office.
Which never happened.
Right. We just print different things now. Then in the 2000s, we were told the semantic web would change everything. Then in the 2010s, it was blockchain for everything, where people were literally trying to put iced tea companies on the blockchain just to boost their stock prices.
I remember that.
And just a few years ago, in the 2020s, we endured the whole metaverse is the future of work phase.
Right, and the pattern is virtually identical every single time. During the peak, we are promised 10x productivity and a total revolution. But gravity eventually applies.
It always does.
While genuinely useful things do eventually emerge from these trends, it only happens after the massive hype bubble deflates. The tourists leave, and the engineers quietly step in to clean up the mess and build something practical. Reality always calls us back to Earth.
Okay, well, let's unpack this, because we all want the dream, you know? The author makes a great joke about HAL 9000 from 2001, The Space Odyssey.
Great reference.
We would all absolutely love an AI that's intelligent, preferably one that doesn't go rogue and try to eject anyone out of an airlock. But right now, we're in a spot where overall software quality seems to be plummeting faster than our enthusiasm for the next big buzzword. We're just tired of faulty apps and fragile services.
Yeah. So how do we demystify this? What actually is agentic AI when you strip away the magic?
To understand it, we really have to look past the marketing and break it down to its absolute core. Vendors are throwing everything into the agentic basket right now.
Which makes it incredibly confusing for anyone trying to buy or build these systems.
Exactly. But if we strip away the glitter, we can look at a classic internet automation principle.
It really all boils down to the old, reliable, if this then that logic we've all used, but on steroids.
Yes, IFTT.
IFTT is beautifully simple. It's a foundational automation concept. If this happens, then do that.
The source gives some really grounded examples for you to visualize. If I receive an email from my boss, then create a task in my to-do app. If the temperature sensor outside drops below 5 degrees Celsius, then turn on the smart heater.
Or if a new design file is uploaded to the shared drive, then automatically notify the team in the chat channel.
Exactly. It is strictly deterministic. It is completely predictable. It does exactly what you tell it to do, nothing more, nothing less.
And that brings us to the core engineering definition of agentic AI from our source. When you take away the buzzwords, agentic AI is essentially just an extremely sophisticated version of that exact same idea.
Just a fancy if this, then that.
Essentially, yes. It is a large language model, an LLM wrapped in a control loop that can plan steps and call tools or APIs to act in other systems until a specific goal is reached.
Wait, if standard automation is just if then, how does injecting an AI actually change that? Does it just guess the then? Because it sounds like you're taking a reliable process and making it weirdly open-ended.
That's the crucial shift. The if is now being interpreted by an AI, and the then isn't hard-coded anymore. It involves dynamic choices.
Okay.
There are three main components making this happen under the hood. First, you have a language model, which acts as the brain interpreting the text and deciding on goals. Second, you have a set of tools.
Just to clarify, for anyone picturing physical tools, we're talking about APIs here. Think of an API as a digital waiter taking the AI's order to another piece of software. It's how the AI talks to your database, your email server, or an external service.
Precisely. And the third component is the orchestrator loop. That orchestrator loop is the absolute heartbeat of the whole concept.
The loop.
Yeah. It conceptually breaks down into a 5-step process. Step 1, understand the goal. Step 2, decide on the next action to take. Step 3, call the appropriate tool or API.
Hold on. Step 4 is observe the result. So it actually checks its own homework before moving on.
It does. It looks at what the API sent back and asks, did that work? And step 5 is simply, repeat the process until the goal is declared done. At its most fundamental level, it's really just an API loop driven by a language model.
Sometimes it's literally just a few dozen lines of code, and sometimes it's a massive framework. But people are selling it out there as if they've somehow achieved nuclear fusion at room temperature.
The hype is real.
I'm having a hard time picturing this in my day-to-day, though.
Yeah.
If I wanted an agent to just book a meeting for me, what does that actually look like under the hood without the sci-fi branding?
Well, the source outlines a great practical tool called the Polite Meeting Booker agent.
Oh, I love this example.
It's very grounded. The stated goal given to this agent is schedule a 30-minute meeting with 3 specific colleagues next week, avoid any scheduling conflicts, and send them all a polite invitation email.
Okay, so to achieve that, the agent has a specific set of tools available to it. It has an API to get calendar availability, an API to create calendar events, a tool to draft an email, and a tool to send that email.
Right. And without human intervention, the agent kicks off its loop. First, it queries the calendar API to check everyone's availability.
Step 1.
It processes that data to identify a suitable open time slot for all 4 people. It then calls the next API to officially create the calendar event.
Got it.
Next, it uses its language model brain to draft a culturally appropriate, polite email explaining the meeting. And finally, it either sends it out directly or flags it for a human to approve. Goal achieved.
You know, you have probably already seen this exact thing in action without realizing it. If you use Microsoft Copilot inside Outlook or Office 365, you've experienced this.
Oh, absolutely.
When you toggle on what they call agentic mode, the software uses the context of your emails and documents to rewrite things, summarize threads, or adjust the tone of your writing.
It works, and when it's scoped properly to a specific domain like your inbox, it works quite well. But calling it agentic mode is mostly just adding unnecessary hype to what is essentially contextual automation. If they just called it smart automation, it would be far less confusing.
But it wouldn't sell as many expensive enterprise licenses.
Exactly.
Here's where it gets really interesting, though. We need to draw a hard line between what is just an automated workflow and what is actually an agent. Because right now, the terms are being completely blurred by every marketing department in tech.
The author uses a fantastic metaphor for this. They note that a huge percentage of the shiny agentic demos you see online or at tech conferences are actually just workflows wearing sunglasses.
Workflows wearing sunglasses, that is the perfect image.
It really is. It's standard, rigid automation dressed up with flashy AI branding.
So how do you actually tell the difference? If I'm looking at a piece of software, how do I know if it's an agent or just a workflow in disguise?
Well, a workflow is defined by predefined steps. It's a fixed track. First A, then B, then C. If every single step is predetermined before you hit go, you do not have an agent. You just have a workflow.
Okay, so what makes the agent different?
True agents decide for themselves which tool to call in the moment. They can replan mid-execution if they hit a wall, and most importantly, they operate under uncertainty.
Operating under uncertainty requires a completely different underlying architecture, doesn't it? You can't just slap a chat window on a database and call it dynamic.
No, you can't. To make that dynamic decision-making possible, a true agent requires what engineers call the agent stack. It's not just a language model anymore. You are essentially building a digital brain with distinct cognitive modules.
It sounds complicated.
It is. First, you need planning modules. This is how the AI decomposes massive, ambiguous tasks into smaller, executable steps.
So it's not just following a recipe, it's writing the recipe as it goes based on the ingredients it finds.
Which brings us to the second requirement, memory. A standard language model has the memory of a goldfish. It forgets you the second the chat window closes.
Right.
An agent stack needs both short-term memory, the context for the current task it's working on, and long-term memory to recall past interactions or user preferences from last week.
If we're carrying on with the idea that this is basically a junior assistant you've hired, the memory module is you teaching them how your company works so you don't have to repeat yourself every single morning. What else is in the stack?
The third is tool use. We mentioned APIs earlier, but in the stack, this is about securely grounding the AI to those tools so it actually knows how to format the data it sends to your CRM or your accounting software.
Okay, that makes sense.
The fourth is reflection. These are self-critique loops where the AI pauses and checks its own work against the original goal before proceeding.
A self-critique loop. That is wild. Is the AI saying, wait, did I just do that right? Before it hits send.
And crucially, the fifth piece of the stack is human approval dates. Even with reflection, you need a way for the system to pause and ask a human for permission before it does something irreversible, like deleting a database or sending money.
That stack sounds incredibly impressive on paper. Planning, memory, tools, reflection, approval. It sounds like the future of work. But from a pure engineering standpoint, that exact stack introduces a mountain of problems, doesn't it?
If we connect this to the bigger picture, you are deliberately introducing non-determinism into your systems. You are taking a predictable software process where an input always equals the same output and making it inherently unpredictable.
Because agents aren't actually dangerous because they're super intelligent. They are dangerous because they are connected.
They have hands.
They have hands. They can touch your systems. If you're running a business or managing a team, there are 5 major questions you have to confront before you let an agent loose. Let's start with the first one. Reliability.
Reliability is paramount. If the language model decides incorrectly, which we know they frequently do, what happens to your system? Does it just crash, or does it actively mess up your data?
And that leads right into the second question. Observability. If the AI makes a bizarre choice, can you actually trace back why the agent decided to take action X instead of action Y? Or is it just a black box of machine learning math that you can't decipher?
This raises an important question regarding the third issue, permissions. Does this dynamic, unpredictable loop have access to your production environment? Can it touch financial transactions?
Oh boy.
Can it read sensitive customer data? And more importantly, could it accidentally expose that data to the wrong person?
The fourth question is one that will keep CFOs awake at night. Cost. As we established, agents run on loops. API calls cost money. Language model prompts cost money. How many times will your agent loop trying to solve a tiny error before your monthly cloud invoice starts looking like a telephone number?
A very expensive telephone number. And the fifth question is quality. Just because the agent reports back that task is complete does not mean it worked correctly.
Right. It might have run perfectly and sent a highly polite meeting invite to your biggest competitors instead of your internal team. Which brings up a really profound point from the source text. For decades, computer scientists and developers have been debugging code. You look at the syntax, you find the logic error, you fix it. But with agentic AI, we now have to learn how to debug intent.
Debugging intent is a monumental shift for the tech industry. Think about it. When reviewing code, you are looking for a missing semicolon or a broken variable. When debugging intent, you are reviewing a language model's philosophical reasoning for why it thought deleting a database was the most efficient way to organize it.
We are reviewing the intern's thought process rather than just fixing their typos.
Exactly.
We have rigorous code review processes for human engineers. Capable, trained professionals write code, other professionals review it, and we still discover defects and bugs that bring down entire servers. If that's the baseline for human experts, why in the world would we blindly skip reviews for AI-generated actions that are modifying our real live systems?
We absolutely shouldn't. The ideal framing for an agentic AI right now is to keep treating it exactly like that junior assistant metaphor you brought up. It is fast, it is helpful, it can occasionally be surprisingly creative, but it absolutely requires supervision. It is not a CTO replacement. It is not a senior developer replacement.
So where does this junior assistant actually shine? If we know the risks, what tasks are safe to hand over? According to the source, you want to give it tasks that are multi-step but structurally sound. It needs tools that provide reliable, undeniable ground truth. You must have human approval gates in place for any risky action. You need rigorous logging and rollback mechanisms so you can undo its mistakes. And above all, it should only be deployed where the cost of an error is acceptable.
The source gives some pragmatic use cases that fit this criteria perfectly. Internal IT ticket drafting is a great one. Document summarization across massive, messy corporate repositories where perfection isn't strictly necessary. Customer support triage, having the agent figure out where a ticket should go rather than having it answer the angry customer directly. Calendar coordination, like our polite meeting booker. And even controlled DevOps assistance, provided there are strict guardrails in place.
Let's say you're listening to this and you're feeling adventurous. You want to experiment and see what this junior assistant can actually do for your team. How do you hire one? The source breaks down the current builder's toolkit into 3 distinct categories. You don't need all of these, but understanding the landscape is vital. Category 1 is no-code or low-code automation platforms.
These are your tools like Microsoft Power Automate, Zapier, Make, or NN. These are fantastic for business users or for running very fast experiments with a limited scope. They let you connect different services and inject AI decision steps visually without having to write raw code. Behind the scenes, the platform is handling the agent logic, the loops, and the API calls for you.
Category 2 steps it up a major notch. Developer agent frameworks. This is for the engineers listening who need fine-grained control, reliability, and custom logic. We're talking about things like the OpenAI Agents SDK, which is basically a software development kit or a digital toolbox for programmers, along with platforms like LangChain, LangGraph, Microsoft Semantic Kernel, or Crew AI.
These frameworks give you the raw building blocks. You get the models, the tools, the loops, the memory structures, and the tracing capabilities. If you are using these as the source nodes, you're officially doing software engineering again. You aren't just prompting a chatbot. You are building complex software architecture.
And finally, Category 3, Cloud-Native Agent Platforms. This is for heavy-duty enterprise environments. Think Azure AI Agent Services, Google Vertex AI Agents, or AWS Bedrock Agents. Why would a company choose these over the developer frameworks?
These are critical when you need deep integration with existing corporate infrastructure. If you need complex permission scopes tied to your company's Active Directory, enterprise-grade logging for compliance, and strict governance over what the AI can and cannot access, you need a cloud-native platform. It provides the security blanket that enterprise IT departments require.
But the big takeaway across all 3 of those categories, whether you are using a drag-and-drop tool or coding from scratch, is that none of these tools are mystical. None of them are magic. They are simply software platforms designed to connect language models to tools under controlled conditions. Period.
Period.
So what does this all mean? For you, the listener, let's bring it all together. Agentic AI is a real technology. It is not entirely vaporware, and it is definitely here to stay in some form. But right now, we are wading waist deep through the hype phase.
The author gives a fantastic piece of advice for navigating this phase. Treat Agentic AI like you were just handed a brand new box of Lego. You should explore it, you should build with it, you should absolutely experiment to see what's possible. But do not throw away your foundational engineering judgment just because a vendor slapped the word agentic onto a PowerPoint slide.
You still need to ask the 5 whys when a problem occurs. You still need to demand a measurable return on investment before scaling an expensive AI solution across your company. You have to insist on logging and the ability to roll back changes. If you're deploying an agent, start it in read-only mode so it can't accidentally delete your database while it's learning, and always add a human approval step for any critical action.
Exactly.
If you've been feeling left out of the craze up until now, I want to reassure you directly. Relax, take a breath. You are not behind the curve. You are simply standing slightly to the side. You are standing exactly where the seasoned engineers always stand, waiting patiently for the hype storm to blow over so the real practical work can finally begin.
And to leave you with something to really mull over, let's look back at the mechanics of how these agents operate. We established that agentic AIs are fundamentally just loops that call APIs until a programmed goal is reached. And we know those loops cost computing power and money every single time they run. So what happens when 2 different companies unleash their agentic AIs into the wild, and those 2 autonomous systems accidentally start arguing or negotiating with each other in an endless, unsupervised loop?
Oh, wow.
Could an unchecked, smart digital assistant bankrupt a small business's cloud budget over a single weekend before a human ever steps in to hit the off switch?
Now that is a terrifying and entirely plausible scenario to chew on. Thank you for joining us on this deep dive into agentic AI. Keep experimenting, keep asking the hard questions, and we'll see you next time.
Thank you for listening to the Agile Engineering Deep Dive podcast. If you found this episode valuable, feel free to share it with someone who might benefit, a colleague, your team, or your network. You can access all episodes by subscribing to the podcast and find their written counterparts in the Agile Software Engineering newsletter on LinkedIn. And if you have thoughts, ideas, or stories from your own engineering journey, I'd love to hear from you. Your input helps shape what we explore next. Thanks again for tuning in, and see you in the next episode.